this in the future. Today I'll continue the work on doing rather creating a level editor for the game here. Let me see, I just need to fix the YouTube chat here. Doesn't it work? Maybe not. Maybe it's not live yet. It should be live though. Let's see. Did it change the link? No. Okay. Interesting. There we go. Let's swap that for a live chat. All right. So I've been contemplating how to do things in terms of the level editing system. Hello, welcome. I do think that yeah, of course I do. Good morning. I think you were the first to join the channel, yeah, or rather stream. And Fanbia close second, I guess. And good morning to you too, Fanbia. Um, so as I was about to say, I was contemplating how to do this level editor system here, and I think that, yeah, what are you planning to add? I haven't implemented the actual transient one, but imagine that we have static objects that are seldomly updated, meaning that their information doesn't change very often. They preferably never should change, meaning that it would be static environment meshes that have the same transformation matrix, the same texture transform, the same material and texture and so forth. So they are entirely static and should reside only on the GPU default heap. They should never be in the dynamic heap because that is slower for the GPU to access. A dynamic object should be something that might be updated regularly. Therefore, the information about the object in the renderer could reside in a dynamic heap and just be updated whenever it has new information. And transient objects are supposed to be transient, meaning that they might exist for some frames and then they're gone, which means that this will be provided by the CPU for each frame, and it will consist of lists of objects that need to be allocated specific draw calls. Yeah, exactly. And the dynamic objects could be something like moving doors or uh, buttons or whatever. Uh, meshes or yeah, meshes of enemies, of course. But the static objects would be the environment. Um, so yeah, I thought about adding frustrum calling in the future so that we do a kind of draw call buffer for each, no, for the first two kinds of objects here, since these are submitted by the CPU for each frame. We won't create any buffers for that. And we reference the uh, draw calls in. Yeah, yeah, I'm actually gonna change the renderer a bit. So right now, um, it has this is actually the transient game object data. As you can see, the CPU copies over lists of game objects with their transforms, their texture transforms, and according to their meshes. So this happens each frame, which means that the object is created and then deallocated during the end of each frame. So it's actually not dynamic, it's more transient. Well, but yeah, we will refactor this a bit. So we need functions that can add a static draw call, modify slash update a static draw call. Hello and welcome. Yeah, that sounds interesting. Are you using I'm GUI or doing everything from scratch or? And of course remove a. It takes a lot of time, doesn't it? Draw call. Yeah, I know that feeling. Yeah. Okay, let's see. So we would also like Yeah, that sounds nice. The scroll bars are a bit of a challenge, but dynamic draw calls of interface of the same type. Okay. Submit transient data. Let's rename this because, whoops. We will do that because, yeah, the whole point was that I'm going to change the level editor system here because we want the container, we want to um, store, save, and load a series of game objects, but we don't want this functionality. We want for the um, level system, we'll have the object store. We don't need a dynamic mode only because we will simply allow the renderer to update static objects and remove them. We are really not bothered with what do you call it? We're not going to be bothered with. Oh, I lost my train of thought. I was contemplating something else. We don't care that much about performance inside our level editor, which means that we can simply just modify the static objects. Yeah, and we should be fine. It requires a copy on the command queue for that, but we can do that asynchronous, and we can also do a collection of updates if we want to, but it will only be slightly slower than our regular mem copy on the CPU side. So yeah, we should be able to do that on a per frame basis. So yeah, there's no need to make all game objects dynamic. And also one thing I realized when I was contemplating this, we won't be modifying groups of objects, for instance. We could do that if we do nested game objects of sorts, but our system doesn't really support that for now, so that's not really a priority. But either way, it would be fairly easy to implement a listed version of updating static objects or even pooling both static and dynamic objects into a single update step or a series of update steps. Well, Mr. Yes, you implement lights through materials and light calculations inside your shaders. If you watch the tutorial, I actually add lights. The only difference is the way that you compute the light. You can do something like, what is it called? Is it called Bling Fong or something? Like Blin Fong. You simply add some shader logic that does a Blin Fong lighting model and create some materials. Well, GLSL and HLSL are pretty much the same. The only difference is how you bind the resources. So you basically bind a data structure with the lighting information, and you bind a material. Well, shaders kind of work the same. It doesn't matter whether they are written in GLSL or HLSL. They're pretty much the same. It's just small programs that compute different stuff over different data, and the data is bound to the pipeline through the API. Even the function calls are probably mostly the same between the two shader languages, and differences can easily be looked up in a Google search. So yeah, but add materials and add um, you should be able to find that it was Blin Fong, but you should be able to find shader programs to do lighting computations due to that algorithm. I think it's fairly basic and widely used. You could probably even find a GLSL version of it. That's probably more likely than an HLSL actually, because those seem somewhat more rare. Most people use GLSL either due to OpenGL or Vulkan, but they're the same. Anyway, let's see. So, yeah. So our system here will only handle one object uh, per edit, and even if we add nested objects, which require no problem, man. Which require updating of several game objects. We can even implement methods for that. So let's do some stuff here. We want to add, I'm not sure what the naming should be, but add static object, update static object, and remove static object. Also, I would like for our draw calls here, not the debug draw calls, but the the render draw calls here to store the object game object IDs so that we can do linear searches whenever we want to update something. Let's see. So let's add that transient data. Well, that doesn't really matter because we're not going to reference that inside the transient data. Even though we're changing all this, we would like to access our game objects here, i.id, and simply store that. In the future, I would like a handle slash globally unique identifier system, but I have to remember that the way of this series is to implement as fast as possible and then do adjustments later on. Hopefully our system will not get too convoluted so that refactoring is that too much of a problem, but yeah, we will do that. Anyway, so we stored the game object on our draw call now. Actually, I would also like a way of adding a list of objects and static objects. Let's spell it correctly. Okay, so this will take a list of objects, and we will migrate this. Let's see, we want to change this. We want a method instead. Create mat mesh mat data, because we will be decoupling the game objects, the transforms, the texture transforms, and simply do uploading of our materials and meshes. Also, I was contemplating actually removing this. Yeah, we could do it in a different way. But this would take materials. It would take a series of meshes. Let's see, mesh. Do we ever reference this? Oh, we don't. But let's just create different methods for this. We might collapse them, but in the future we would like to be able to submit new materials and use those. So for now we will create several functions, create meshes, mesh data. And for now, this is not even a reference, it's copied. Okay. And inside our OBJ thing here, I don't think we actually used it buffer here. I'm not sure that we actually need that. Let's see. Do we have a problem here? Yeah, we didn't use that anymore. No reason to do that. Let's see. Okay. So we want vertices. Normals, I think. UVs. And indices. That means that now we can move these different things outside of that function and start removing that. Maybe the level editor slash level itself should actually create these resources. Maybe the application shouldn't create them. Yeah. Yeah, we could do something like include the renderer here. And we could add a initialize here, a const renderer pointer renderer. Renderer const renderer pointer. It will be kept alive by the application, so we shouldn't have too many problems actually storing that. Let's see, mp renderer. Let's see, let's give it our address of our renderer here. And then our loading of our level will also be creating our meshes and stuff like that instead of the renderer. So, or rather the application itself. It makes more sense that whenever the level is loaded, that different resources are pre-allocated directly. I mean, the application is a coupling between the different systems. So it's fine that it references the level system, I guess. And it's data storage, which we might even not use. Let's see. Uh, so on a load level, we do that before we We initialize the renderer so we can use that. We load our level. Yeah, we should do something like, for now, we will, we can do it right here. When we load a level, let's see, I think, let's see if I close the scope here. If we ask our renderer, p renderer here, whoops. Now we can't change it because it's const, so we can't do anything with a const pointer. Well, now we will ask our renderer to create some material data, materials, and we will ask it to create some mesh data with our meshes here and our, let's see, collapse delights, materials, meshes, our OBJ reader here. This is just bugged no matter what I do. I don't know why IntelliSense doesn't realize that this is a scope. I mean it. Oh well. So we will ask our OBJ reader here for our vertices. Let's see. Yeah, this gives us a reference. Our get normals and get UVs and get indices. There we go. And then we want to tell our OBJ reader to flush the data eventually. Okay. Let's move the logic inside our renderer. Materials preloading. We need this is internally accessible, so we simply move this. Did we actually create it? No, we did not. There we go. So now we have a separate function to create our materials, and everything should still be exactly the same, except we need to failed. Let's see. Oh, I should probably create this whenever I call it. Okay. Yeah, everything still works as before. Let me see what's tanking the system here. Something is slowing it. I think maybe it's just all of the different applications that are run. Yeah, it seems like it. Because we haven't really changed anything. Yeah, it was probably the OS doing some scheduling. Okay. Next, we want to move the mesh data into our function here. Let's see our vertices here. Let's remove this. Great stuff. So now we have the possibility of creating some mesh data, some material data, and we will remove the flush data here. And we will add it to our level system here. Great stuff. So now we only have our game object stuff here inside our preload static data item. So that's the last thing we want to migrate into a specific method. So if we implement the list-based version, let's see. Actually, I think this should be const because we're not modifying it. It might speed up things a bit. Let's see, let's add the const here. Let's just copy that. There we go. Oh, we actually do modify that one. Constant buffer index. Well, that's nice to know. But do we need to know it? Right now we're not accessing it. Are we? When we create the objects themselves, yeah, we actually do, I think. Material. No, we don't. We will delete that for now. Let's see, let's convert that to a void pointer because it's supposed to be the same. I don't know what's happening with this scheduler, man. I mean, I should probably clean my Windows install. I mean, yeah. This scheduler is all messed up. I think because we shouldn't be doing any calls that actually waste a lot of time. Let's see, what if I just... Well, usually when I run the program itself, let's see. Compiled without the debugging layer on it. Let's see if I do something like this. Yeah. Everything supposedly seems to be fine. We do have some frames that kind of like, hello, welcome. Nice to have you here. Yeah, we should do some releasing as well. I think if I simply disable the large part of the UI system here, uh, the performance probably would be more stable, which could indicate that it's related to a bit of allocation, deallocation, reallocation stuff here. Let's see. Uh, I need to tune up the yeah, UI system eventually. Let's see. As you can see here, we're back to almost 6,000 frames per second on some frames. Yeah, so it's definitely the UI system that is doing a lot of the problems. We do have the occasional scheduler interrupt, I think. Yeah, so I am making a game. Uh, it will be a Doom slash Quake clone. Right now I'm creating a system that can allow in-game editing of the levels. So we don't need materials, we don't need, but we need game objects, a list of game objects, their transforms and their texture transforms, and then a series of meshes from which to describe the data. We could also add that first. I don't know. It doesn't matter at all. These are supposedly being constant because we won't change these. Oh, interesting. Which ones are you learning? Let's see. So we will create that. Create mat data, mesh data, debugging buffers. That's fine. So we will simply move this. For now, it will be a hard-coded list of sorts. So our level system here will tell the renderer that we want to add some static objects. Create add static objects here. Game objects, static game objects, meshes, transforms, texture transforms. You think Java is hard to understand? Okay, let's do that instead, and let's decouple this. Finally, we can delete that whole scope. Okay, and we should still be all right, hopefully, if everything compiles. Yeah, we've successfully migrated out of that function, and we can now delete it. Okay, so now we can actually add lists of game objects by using this. It will actually allow us to create a series of game objects on the fly, meaning that we can use this again and again and again to create our resources here, and they will all automatically get drawn. I think that we would rather write this in a different way. This should be allocated like that, and then our temp object data index number whatever dot material index is what we're going to use here. So This should be exactly the same, except if I do not remove the, there we go. Preload static data. There we go. It's exactly the same. It's just probably way more efficient to simply allocate whatever we need to allocate and then update the values instead of using temporaries. That's just wasteful. Okay, now let's use create a singular version of this. So we want a game. This could be const. As you saw, nothing got modified. So let's just set it as a const. Game object reference. A mesh game object. A mesh reference. Mesh. A object transform. Reference transform. A texture transform text transform. Okay, so we can now add a singular static object. I don't know, Greenfoot, what is that? Is that a programming language or a game engine or? Well, we of course need to offset by whatever. Well, we can use the allocate for now. Yeah, since we will replace allocate with some stale indices whenever we deallocate. We will do that anyway. We could do sort of a queue system. Where we allow ourselves to add different objects and then simply call the upload here by itself. Let's see, upload. Let's see. If not, we return. There's nothing to do. Whoops. Do we not update the right head here? Yeah, that's maybe our problem here. Copy texture region. This is texture. Yeah, we do increase the right head, so some data does get transferred. Okay. Let's see. Total bytes. This should be the fix that we need. Yeah. So if we haven't written anything into a buffer, we will of course not upload anything because it doesn't make any sense. Yeah. A small bug. Anyway. Let's see. Linear buffer. Upload. It's probably related to some branch prediction stuff here. I'd reckon. Anyway. Yeah, I think actually. Huh. Let's just check out the UI here. I think record window. No. Yes, no, yes, no, yes, no, yes, no. Frame data. I'm pretty sure that yeah, it will probably resize. Anyway, that's a fix for a later day. Yeah, the UI system here definitely has some performance issues that I should fix. But it's funny that it seems more performant whenever I use the whole UI. Which would probably relate to some allocate, deallocate stuff. This is the anyway. Yeah, I'll definitely look into that in the future. Anyway, we fixed the linear buffer. Um, I was considering we have that on the update function now, which is fine. It will just return if there's nothing to upload. This means that this call here doesn't, or rather this one up here doesn't need to call that. Let's create some stuff here. So and let's set this to const because I think it's const in the declaration. No, it's not, but we will make it const. I also think the game objects actually are const. Oops. Oh. Whoops. We actually don't need this. Let's see, object data. object. Well, the problem is that without the upload, this data will be dereferenced. Okay. Mesh ID index const unsigned int transform index const unsigned int text transform index. Since let's change this. We don't need the mesh index. Actually, but we want the. We don't need the transform index either. We need texture index instead. Transform index doesn't need that. Don't need that. Let's see. So we actually just need a const texture index, const unsigned int material index. Whenever I queue the upload, the memory there is stored on the buffer itself. Yeah. So what I need to keep this alive. Well, is it faster to copy these values than it is to well, it should take some time, buddy. Okay. Actually, I would like these to be placed like this. It seems somewhat wasteful to copy this But I guess we will do it. It will get stored in the internal buffer. Hmm. Mm. Ah. Mm. Let's see, allocate. So it's potentially 0. Yeah, so no need to subtract it. Okay. Let's test this, because we should be able to use our level system here. Let's delete all this. Let's delete this function here, or rather this value here. Let's remove some stuff here. All of this here. 250. 400. Let's do that. Let's create a function UI system button here. Let's use the UI namespace in the CPP file using namespace UI. We don't need to do this anymore. Button, MP editor context, add static objects, and let's put this in an if statement. If that's true, we'll create a game object, temp object, that will have equals to static game objects dot size. Let's create it with the zero mesh here. The texture 0. I think that's just white. The material, base material here. Let's see, and we will add a transforms size here. Object transform temp transform here, and it should be initialized as a identity matrix, which should be fine for our needs. So let's add static game objects in place back our temp object here, and object transforms. We want texture transforms right now. Well, I'm just gonna support it. Transforms here. Texture transform. Temp text transform. Texture transforms, where we place the temp texture transform here. And inside our renderer here, we need to pass the material index and the texture index. So let's not move this since, whoops, that's not the right place to be. Here we go. Let's not move this because that will invalidate the data. Okay, let's try adding this static object to our renderer here. Let's see, can we just pass it the temp object and then the meshes with the mesh index of this, and then the material index, and then the texture index. Let's do the opposite order here. And then what do we want? We want the transform. It will copy the data to the buffer, so I'm not concerned about the actual lifetime of these things. Let's try that. It's not certain that everything works out in the first try, but it did. We simply added a static object here. We can actually add one more, but we can't see that. Great stuff. Okay. We have added static objects and they get uploaded to the GPU each frame. Next, we want to modify our object. We could do some hacky stuff. Which would use more memory and give us some clunky information to store, but we could add the allocation index. Let's just modify this. So we could add the allocation index, which we actually assign here. Because we could change that on the underlying game object. We could also add a draw call index, so that if we wanted to modify the draw call itself, for instance, change the either the allocation, because we want to create a new allocation for some weird reason, or if we wanted to change the mesh information here. So one approach is create draw calls with a game object ID, search through draw calls, let's see, draw calls, and find draw call with correct ID, and update the constant buffer through the allocation index. Or we could simply store the draw call index, which will contain the allocation index, access the draw call buffer directly with the appropriate index, and look up / change information. This would require us to change the game object, store a bit of data on our actual game object. Well, yeah, I just realized a performance heavy thing in our input system that we want to change. Anyway, I think this will definitely be the most performant because we have random access through the vector itself. And this would mean that we would have to iterate over each object. And yeah, I think we would store the information no matter what. So instead of the draw call having a game object ID, we change the game object here. maybe temporary renderer coupling to avoid linear searches for objects. Of course, I also need to set the flag here. Let's see, int allocation draw call index, which will be 0, or rather invalidated. And we, of course, inside our application here should set our temp object dot flags. We should bit shift 1 1 plus equals 1 bit shifted 1, because this is a static object. Okay. Yeah. So let's let's change this so that it's not const. Also, this is not supposed to be const anymore. Let's change this as well. So our game objects draw call index will be our static draw calls, that size here. It will be the same up here. Okay, so we store the draw call index, meaning that we can access it directly, and through that access the underlying buffer. Let me fix the problem that I realized is inside the input system here. So whenever we call get mouse position, we actually calculated each frame. We don't want to do that. That's super inefficient. We want to capture the mouse position at the beginning of the frame and store it. So let's store a mouse position frame mouse pause here. Let's see, do we initialize mouse position? Yeah, we do. Great stuff. Get mouse position. It will be an inline function instead, where we return mFrame mouse position. Oh, an instance, of course. Mouse frame mouse pause here. And we will simply move this let's see, our application stores this information. Running. No. Handle messages, is that? No. It's on the run. So it will lag behind by a frame. Does that matter? I don't think so. I don't think so. We could call it last frame. We could also do some stuff where we yeah, because save frame state should be something that we do at the end of the frame. Let's do a static void update where we simply instance. Yeah, I just realized that I'm actually pulling the mouse information through so many different UI elements. Then for each UI element, I have to pull the mouse position through this method here. And actually, I just want it to be stored on the input system each frame. So let's see, handle messages, input. Let's using namespace input. No. I'm just changing a bit of functionality here. Uh, because I realized that I was being highly inefficient. I was calling a method over and over again, and for each object in the UI system, and that doesn't make any sense. That's just way too slow. So now we do this each frame. We store the data here. Maybe actually, does the application on create, on update, doesn't store the we could change this so that we could pass along the handle, but I don't think it's that expensive to call this. Anyway, since we've just rewritten the function here into a inline function, I think everything should still work exactly the same. Okay, yeah, everything seems to work exactly the same. That's way better. That's way better. The only situation would be where you would use something like that would be in a highly restricted uh, memory restricted system, but then you would sacrifice a lot of CPU cycles not using the memory, and since you have to allocate on the stack, yeah, it doesn't make any sense. Doesn't make any sense. Okay, maybe that will speed up parts of our UI system here. Uh, it's definitely not gonna make it slower. Maybe that was why the OS scheduler kind of like freaked out from time to time, because it was like, why are you asking me where the mouse is? Several thousand, maybe tens of thousands, or even 50,000 times a second where the mouse is. Why do you want to know that that often? You can't be doing enough precision work for that to make sense, but oh well. Sometimes you just realize that you've made a silly implementation. Yeah, I couldn't let the feeling go that that was really bad. I was trying to focus on doing the other stuff, but the realization made me not able to focus. Anyway, so I fixed that. We're back in terms of our static object stuff here. We store our draw call index, and through that we can access our constant buffer allocation index without the need for searching. So let's try doing a update function. We will pass in a game object reference, and probably a object transform here, because that's what we will be updating right now. Transform. That's usually what we want to update, but we could um, pass in some mesh information. Yeah, we want to be able to update the mesh and the transform, and we can update the texture through the game object itself, the material as well. So let's try doing that. And we won't change any of these. We might change the game object so that will not be const. All right. Let's do some static updating here. So let's create a render draw call pointer here. Draw call, which will be our static draw calls indexed by our game object dot draw call index. Let's see, and we of course need to reference that. Yeah, so now we have access to our draw call. We could do some mesh calculation, but in order to test this, we will just update the transform. And to do that, we will queue an upload, which will be based on our draw call, constant buffer index. And we will allocate the amount of data. Let's see, we will simply pass along the, let's see, the object data. Okay. We need to compile some object data here. Okay. We can't simply do that. Obj data. And we will compile that data. The world matrix will be our transform matrix. The object data material index will be our game object dot material here. Our object data texture index will be our game object texture. And that should be it. We're not changing the texture transform. Let's see. It's already pre-initialized as a identity matrix, so that should be it. Let's try updating, or our object here, system button update texture. And we will ask the renderer to update static object, and we will reference our static game objects back. Pretty big back though. Okay, we will do this as a pointer just for ease of use. obj pointer p obj will be the reference of this. So let's dereference our p obj pointer here and access it here. Meshes p obj mesh and transform. There we go, and let's change the underlying value. Let's see, let's increase the texture. All right, let's see, let's create a static object. It does change the texture, but not what I expected. The back pointer, add static object. Oh, now we have an exception somewhere. Well, that's definitely not. Okay. Let's see, we don't need this, I think. We don't need this for now, do we? No. Okay. Let's do some level editor data. Let's do something like editor object index, which will be 0. Let's see, let's close this. Let's set it to our static object size here, and then we can reference that. Let's see, whoops. Yeah. It seems like it's updating the wrong object here. Oh, it will be increased by what? No. Let's see. Whenever I press this, I want to access this value here. Alloc index. Let's add an object. The alloc index is 1. Huh. The draw call index. Oh, I don't set it on anything else but um, oh, I do. I do. Okay. Let's see. Let's debug this. Let's start out here. Okay. The current editor object index is 5. Let's see, static game objects index 5, which seems fine. Let's see, draw call index is not initialized here. Oh, wait a minute. It's because I pass on a temporary. That is why. We're not updating the actual object. There we go. Okay, it was the debugging thingy. Yeah, there we go. Okay. So that works. Great stuff. Great stuff. So now we add game objects through our editor here without problems. Let's try deleting game objects. Let's see, UI system here. Button. Delete object. Let's get a game object reference. This could be const because we're not going to change it in here. We're going to change it outside when we're done. Let's see, move an item to back of vector, C++. Let's see. Uh, mm, Fastest way, remove item from. Well, the problem is now that we've created a system where we're dependent on the draw call index. That's not great. That's why the search is the search is probably no. Is it? It's not more robust. We could do one simple thing. We could simply just nullify the underlying transform. It's kind of hacky because it makes the draw call anyway, and the GPU has to spend time on doing that. We could reassign each index. Let's see, DirectX. Draw call 0. Yeah, that's the problem. And the buffer might resize, so we can't reference it. That's the problem with vectors. Yeah, I would like a page system instead. But that doesn't solve anything right now. So yeah, we could just do the hacky thing, but the object would still live in memory, and we could end up in a situation where we got an overflow. This means that we need to change the underlying system here. Mm. Deallocating the object would reshape the vector. We could do an algorithm that reshapes the draw call indices for everything after the removed object inside the draw call buffer. Yeah, so if we do not allocate, I mean, the game object ID could increase forever. Meaning that a new ID could have a very large, or rather new game object could have a very large ID. Yeah, so I think whenever we yeah, the problem is, do we want the well, do we want a linear search in both our object update and our remove? Because if we remove, we have to re-update. Not only do we have to move objects in one vector, we also have to update the values of a series of entry points in another vector to accommodate that new indexing, and it would revolve around a lot of logic because we would have to handle 8 edge cases where there are no previous. Oh no, the previous case wouldn't be handled anyway. So, but the problem would be that, well, we would have some sort of semi-tight coupling between the game object lists and okay, let's try reducing the linearity of things into only one function, it might not be the best solution. But let's see. Let's pass in a vector of game objects. We will only update the underlying value, so we shouldn't run into problems. Game object list. Okay, we will do it like this, but it could definitely be done in a different way, because let's store the draw call index. Because every game object yeah. It will work, but for instance, you could just do something like for in I equals draw call index, and while I is lower than the game object list, that size increase I, and then for each object on the game objects list, we decrement the draw call index. This should work. We will only iterate over a series of objects here. We don't need to scan fastest way to delete vector element C++. Let's see, one position. Let's see, most efficient. Let's see, what do people suggest? Let's see. Okay. std erase. Index. Okay. Let's do a m static draw calls that begin. Yeah, we will just ask the system here to erase, since it's only one element, static draw calls in plus the draw call index. Okay. We could add some allocator, deallocation, stale indices, released and reused on allocate. We could do that. Remove static object. We will pass in a dereferenced pointer to our object here, and then our static game object here. Let's try doing that. Add a static object, delete it, add it, delete it, add it, update the texture, add another one, delete that one, delete this one. Great stuff. Okay, now we can remove, and of course we need to erase that as well. We could potentially, if we yeah. Do we ever use the ID for anything? I don't think so, at least for the static objects. But we might. We might. Okay. I think that sped up our application as well. Add a static object, update the texture. Okay, great stuff. Great stuff. Yeah, that's probably a fairly okay way to do it. Since we don't even have to iterate over several objects. We could add the whoops, allocate function here. Let's see, inside the buffer allocator class. We could simply store a vector here of stale indices, and we could create a void deallocate const unsigned int index. Okay, these are the inline functions. Frame reset. I think this is supposed to be up here. There we go. Let's see. Let's clean up some stuff here. So when we deallocate, we simply let's see, we add stale indices, we push back whatever index here, and we can We can check if we have any stale indices, and if we do, we we'd simply start from the back, and then we can return the index here. We also want to pop it, of course. Yeah. So now in our renderer here, whenever we remove an object, we want to deallocate for now. Let's do this. Constant buffer index. There we go. So this will free up the buffer whenever we deallocate this. It should still work fine. Delete object, add object, delete object, add object. Let's see. Let's inside the allocator here, let's just print out whenever reuse the buffer index here. Yeah, it works fine. Great stuff. This means that our data now is arranged in our memory in a fairly compacted way, and we won't get closer to our, what is it, 256 objects that are currently possible to allocate on one page. Yeah, 256 objects. Okay, so great stuff, great stuff. It turns out that adding static objects and uploading their data to the GPU is not that CPU intensive. So when we do our level editor here, we will only handle static objects mostly. We could, yeah, we could probably do some logic where we handle the objects differently depending on whether they are dynamic or what. Okay, so I think so far we've done a lot of good work. I need a bathroom break and maybe a small cup of coffee before I continue on. So I'll do a short break, maybe 15-20 minutes. And what we have next on our to-do list here inside our level system. Let's see, what did we originally plan? Well, we I'm not leaving for today. I'll be back. I'll just leave the stream running. Oh, Sure thing, buddy. Did you get your light system up and running? Let's see. Uh, I asked you if you got your light system up and running, or are you still working on it? Oh, okay. Are you getting closer? Have you added materials? Well, did you look up the lighting model? Uh, well, what is the problem? Well, you calculate the pixel color from, you sample your texture as normal, but you need to interpret the pixel color intensity in a range from completely black to up to your required pixel color due to your texture, and you use the lighting model to amplify or decrease the color per pixel according to your texture sampling. So have you created normals on your objects as well? Because without normals, you can't really do lighting. It seems like this article here has the implementation of the blindfong shading. Ambient light, diffuse light, and specular light. And your color is always um, the color might be hard coded in these shaders. Let's see, fragment color. It seems like the fragment color is set, but that will be just your texture color from the sampling itself. So you simply add, if you do regular texture sampling, you simply add the lighting step afterwards. Are you still here or did you leave? Okay. For instance, let me show you a basic shader here that does the lighting stuff. It was just the YouTube panel that said that nobody was watching the stream, so therefore I got confused. So in this pixel shader slash fragment shader, call it what you want, it's basically the same thing. I sample the diffuse color, which is the reflection of the object when light shines upon it. No matter, uh, in lighting, it's light uh, with a certain color hits an object, and the object uh, reflects lights in different parts of the light, meaning that a red object reflects mostly red lights, a blue object reflects blue lights, and so forth. So we sample the texture here, since the texture is the diffuse color. And if the material itself under the texture has certain properties where the material, not the texture, but the material determines how much light is reflected, I multiply that by it. So you could use this as just basic texture sampling without any material properties written into it. So the diffuse color will be what color the object reflects or has, um, um, no matter, yeah, um, as a base, you could call it. You could use ambient lighting set to 111, and you multiply the diffuse color by the ambient lighting, and you would get a totally lit object that has no shadows, no dark areas, no nothing, because the ambient light is very bright uh, and shines upon the object from all directions. So you sample your texture, and that's the base color of your object. Then you do lighting computations in relation to uh, the normal in that you have processed into clip space in your vertex shader. The normal is interpolated between vertices on a per pixel basis. You calculate the relative position of the camera in world space coordinates to the vertex, so you know where you're looking from, and you use that to calculate your lights. And once you calculate your lights, you end up with a lit color that is a combination of the ambient color from the ambient lighting and whatever directional lighting you compute. And you simply return that as the result of your pixel shader slash fragment shader. The material data controls the Fresnel and roughness and so forth of the object. But start out by doing the ambient lighting. No problem. But make sure you have your normals and your camera position uploaded to the shader. Otherwise, it can't do any vector computations in terms of the lighting directions. Okay, let's see. I'm just gonna write out this. No problem, man. It seems like this guy actually created a bit of a tutorial where he uses ambient lighting, diffuse lighting, and a bit of specular. So maybe read his article. I'll post it in the chat. Yeah. Okay, dynamic objects. Renderer needs to support dynamic objects. Rename the dynamic stuff to transient. Okay. Okay, so this is the outline. Okay, and all right, buddy. I'll probably just end the stream. Good morning, Georgie. How are you doing? Let's see. UI functionality that needs to be added. Custom list boxes. can create the content dynamically outside of the UI. Nice features. Drop down menu. Checkbox. Right, so that's the plan. Um, in order to do the proper UI setup here, we will just modify the custom list box and add some functionality for some of this stuff here. Yeah. We need to later on uh, application set application state edit mode pause physics, for instance. Play mode. Debug. On, off. Yeah. That's some stuff that needs to be added. Let's see later on. UI. This is of priority. Okay. I really need to have that bathroom break, so let me do a 15-minute break or something, and then I'll be back. Let's see. Be right back, maybe. All right, I'll be going AFK for 15 minutes. Can you add some gizmo here? Timer or something? Yeah, maybe I could add that if I wanted to. All right. Okay, this is probably better. Yeah. Let's just change the size of this. And then Yeah, that's probably better. Okay, I'll see you in a bit. All right, all right, all right. Let's see. Refresh browser, shut down when not visible. Let's just set this so our YouTube chat here will behave more appropriately. Let me see, can I actually remove sign in OBS restream and YouTube chat browser. Uh, well, okay, maybe I shouldn't bother too much with that. Uh, let's see, can I find some, whoops, not videos, images. Remove this from your YouTube chat, okay. Let's see. What does this guy suggest? Okay, I have to change it in the stream setup. Okay. Whoops. Yeah, buddy. I'm back. So let's see. We got rid of the hard at least whenever the browser remove the sign in. Uh, I mean, what if we give it full access? Well, that doesn't change anything. Okay. Usually I can't interact with this part. Uh, okay. Let's refresh it. Okay. Refresh browser. There we go. Oh well. I guess I could do real multi-streaming, but well, we ain't gonna do that yet. Okay, should we just get going? That's what I'm thinking at least. Instead of browsing the interwebs. Let's see, custom browser docs. Yeah, maybe I actually want this on my local screen because I sometimes can't see. Let's see. Okay. Apply close. Um, well, that's definitely not what I intended. Uh, at least now I'm signed in. Okay. Um, now I have a. Well, I guess. Okay, I have a solution where we will probably remove the live chat from YouTube since I now have a panel that is able to contain the chat itself inside OBS. Yeah, and it will be live as well. So we could use the restream chat as a chat log. Yeah, I'll fix that. Okay. At least now I have access to the YouTube chat here in OBS. Okay. Okay, okay. So in our application here, or rather our UI system, we want to make some small adjustments. Our list box function here is a total list box, which is fine, but right now it creates all the elements and we have no control over these elements. It would be fine for a list box that yeah, well, needs to be auto-generated for some reason. We will create another version of this, which will make this public text field. Let's do we could do, well, maybe we just want to supply a list of, maybe we want to use this. We could supply a series of labels for each item. And simply just handle our stuff like this. Otherwise, we should do the bounding check twice, which I'm not certain I want to. So this will just create a generic list box. Well, yeah, I think the wrapper is nice because we don't need to double check whether we have started recording the list box. Although, well, I guess we could simply do this in such a way that if this returns true, we must have passed whatever thing we need to do. Okay, okay, okay. We will do like that. So we will do like this. We will begin a list box. With just our number of items here. And then we will do a static void list box end, which will take a context pointer, p context. And then we will have a list box item here that will be placed in between. Okay. Let's create that, and let's create that. Okay. IntelliSense really doesn't like me anymore. Feels bad, feels bad, feels bad. There we go. If we reach this state, we return true. So this means that we have recorded our Windows stuff, and yeah, we're at this state. Let's create. The selected text doesn't contain any function signatures. Well, yeah, right. Somewhere we've messed up the IntelliSense thing for this class here. Somewhere. But I don't know where. Button text. I don't think we should end namespaces, right? We don't do that usually. No. Anyway, I'm just gonna create that myself. So begin. UI system 2. And we will do whoops, not record, and child p context. Great stuff. So now we should be able to record list boxes and end recording them. Let's see if we actually can use that for anything. Okay, so if we UI system list box begin, we want the editor context, we want a test box with maybe 9 items. UI system to list box end MP editor context. Let's see. And this is hard coded. And in our old function here, let's move the button actually. Just move it down here. This is some window handling stuff, context handling stuff. So inside our list box, we create our stuff here. So let's test this code here. Inside our level editor here. So let's do 9 objects here. Let's do some strings. Let's do level system, editor, object index, and our UI system 2 here. Let's update this if needed. Okay. We have 9 objects. I don't have any knowledge of an exact best approach. You have something that you need to render in a 100 by 100 box. So you want the 100 by 100 box to be sort of like a window that you can. So for instance, if you're watching my stream right now, this is a window. So the total size of the contents is bigger than the actual window. So it creates a scroll bar. And this scrolls the visible area of the window here underneath. Yeah, okay, like a view on the image. Yeah, that makes sense. So you need some clipping areas that determines which parts of the image gets rendered. So when you scroll, you could offset the image clipping area. This works by not drawing non-visible objects because they are outside the clipping area, which gets offset by the scroll bar here. Yeah, if you can imagine that the part of the image that gets rendered is determined by a clipping area of sorts. The clipping area would be relative to the total content and determined by the window size / box size. So if your constant starts at 0, 0, on the X and Y and spans a width and a height, you set the clipping area to wherever you want that content to be rendered. So the scroll bar offsets on the y-axis, for instance, or on the x-axis, the starting position of that clipping area. It's like a mask that is applied to the contents itself. I think this UI here processes it like that. Let's see. Whenever our contents is bigger than our viewport, uh, we know that we need it. No problem. Uh, yeah, the scrolling itself here. Yeah, the way this is working is there's a draw cursor that is offsetable in terms of pixels. So each window has a sort of draw cursor that quote unquote draws all the contents, if it's visible or not. It kind of like records the contents, but when you scroll, you kind of like offset that so it doesn't bother with the objects that are um, outside the clipping area. Yeah, it's kind of hard to explain, but um, you basically have two sizes. You have the content size, which is determined by whatever your window would like to draw, and you have your actual viewport size. All right. Great stuff, man. Okay. So our level editor here actually got linked up to or rather our list box here got linked up to our system here. So if we select object number 0, we can change the texture, but we can then select another object. Oh, maybe that's the wall behind me. Okay, yeah, it was the wall behind me, and now we can change the textures of everything. Oh, whoops. Okay, that might be out of bounds. Yeah, I don't think I don't think we have that many objects. So let's do this dynamically. Let's do. Oh, that's great, man. That's really great to hear. Okay, so right now we have these objects here. If we add one more, we get more. So now we don't go out of bounds. We can change our object textures here. Great stuff. Maybe we want this brilliant texture here on the side, or this one. Let's see if one here. Well, our camera here is kind of messed up. Oh, there we go. Okay. I don't like the FOV on this camera actually. I prefer my first person camera here, but yeah. Yeah, so we now create lists of our editable objects, not editable, but editable, changeable, mutable objects in our scene. Yeah. Let's do UI system to text MP editor context. Static objects. Let's see. Yeah, they are highly similar, but OpenGL is just abstracted in such a way that it's fairly simple, but they're basically the same. Um, okay. I don't know. OpenGL, I don't know what that is. Okay. Great stuff, great stuff. In terms of our to-do list here, we added the custom list boxes. Ah, okay. Okay, so next we would like some controls over the objects themselves. Let's see our renderer here. We could update the mesh. We could do some flags where we check if we want to update our mesh, our transform. I don't do unnecessary stuff. Not that it's very intensive. Do we really care right now? Uh, okay. Inside our level editor here. Hmm. So it will always be set to 0. Our scene should have an object at least for now. Okay. We could check if the static game object size is set to something more than 0. We do something like this: object details. Let's do a UI system to text field. MP editor context. Our label here, texture. Char. Buffer 64. Not that we need it, but equal to std to string game object. Let's do game object if the pointer is obj. Let's see, let's initialize it as 0 and then change it. Yeah, I like that interface slash library. Are you gonna make a 2D game or? This should be a null pointer if it's not available. It would be improbable. Does SLDL do 3D? I can't remember. P object. Why won't it access it? Let's disable this. Obj. For some reason, did I mess up somewhere? Yeah, maybe may have messed up somewhere. I mean, for some reason, IntelliSense doesn't. Oh, so you mean something like a voxel system or something like that, which is not really ordinary 3D or. Oh, wait a minute. To string. Okay, let's just cast this to a char pointer. Let's initialize it as 0. Buffer here. Then we need to pass in the integer, I think, and our texture here. Buffer contents, buffer. Two, okay. Well, I guess you could do voxel engines in SLDL, but not 3D models, as far as I know. Um, but I might be wrong. Okay, so we want to give it a buffer here. Yeah. String length of the buffer. And we will simply do like this for now. Let's see what's wrong. Expected expression. Yeah, okay. I understand. Let's see. Do we succeed in creating our buffer here? Yeah, we do. Set the texture to our std string initialized. No, int. What is the convert char to int C++. Array. Let's see, what is the function? Yeah, ATOI. ATOI. Buffer here. Okay. We should be able to change the texture here. What is the rest? Ah, now that is weird. Let's see if we set this object here. Nothing is happening. Ah, well, because of course we do not update the actual information. Let's see. So now we should be able to change our floor with yeah. I don't what yeah, I think the text field here needs to be modified because what if our string length is amount of visible chars? Let's see, we do some calculations. Whenever we render, that's our processing of our keys. Let's see, I set the renderable text. Okay. Let's just do a check here on the, where did I go? Text buffer size here. Okay. Let's do a check here. If it's larger than or equal to the amount of visible chars, we do that. Otherwise, we do the text buffer size. So we don't overflow. 2 BBB, what? We still overflow. Of course, I need to do the same thing up here. Because when it's active, we use the internal thing. If not, well. And of course, we need to multiply this by this, of course. Okay. Great stuff. So let's add a static object. Well, we want to, whenever we click it, huh? I'm pretty sure it's 0. Whoops. Four, one, 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 0. Whenever I delete it, for some reason the value 2 appears. So if I press delete, okay, it's some weird bug. Anyway, it works if I, yeah, and if it's empty, it gets defaulted to 0. For some reason, it doesn't bother. Yeah, okay, but so this is the workflow for our information here. Let's see. Let's do another one for material. Object details, material. Oh, okay. Right now it overwrites the texture matrix. That's why. But we definitely get different lighting properties here. Let's see if we overflow. Well, it doesn't care. Yeah. Material 3. Uh, yes, of course. Yes, of course. I think it's the underlying buffer that doesn't reset. So if we, inside our UI here, context, second list text field, if we don't have a handle, let's see, mem set this buffer here to a 0 value for whatever amount of bytes we have decided that we will do. Let's do a void pointer cast here. So if we delete this and we deselect, yeah. So whenever we aren't the actual handle, let's see. We don't want to use that, but inside our text field here, let's do else if the active handle is not set, but the text field here is internally set. So this will happen whenever our handle, active handle is not this one. Let's reset the handle, yeah, and do cleanup on the next frame. Hello. Help me update your health offset. I'm not sure how your game even works. So I don't think I can help you with that. Let's see. We need a semicolon here. So if we, for instance, click here, and if we delete whatever, it will now clear the buffer. If I delete like this, but don't hit enter, it will reset the value. So that's great. Okay. So if I change a value and press enter, it registers. I think this object is behind me, so I can't see that one. Okay, it resets to the default, which is 0. Let's see if I, yeah, now that one is black. Okay. Great stuff. For some reason, this is still not a scope. Scope. Object. Data. Temp. It doesn't want this to be a scope. Goddamn intelligence. Anyway. Maybe that's fine. So we can add objects, we can manipulate their texture and material right now. We should add some kind of mesh update. Maybe we want to pass on some flags here. Mm. I mean, the UI will probably overflow a bit. Anyway, should we add some flags? Let's do some flags. We could do them as definitions, macros. We could do them as enums. I think DirectX uses enums, right? Yeah. So we could do something like that. They have some flag operators. Well, we could simply do some defines here. Yeah, let's do some flags. Static object handling. Define. exe render flag static update static object flag none equal to 0. Let's do a flag mesh transform. Well, we don't need that because we will probably do it no matter what. I just want a flag here. Const unsigned int flags, which will be set to 0. Const unsigned int flags. If flags and are flag mesh here equals unlike 0. Maybe just do this. If this is set to some value, we need to do some mesh recomputation. Let's do the draw call. How do we calculate them? We For a single object we do like this. So let's just do that. Draw call. And of course we don't want to call that several times each frame. That doesn't make any sense. Okay, update textures. Oh, that's the old one. This is the new one. So let's set a bool. Edit it. Unsigned int flags. So let's do something like if edited. We do the update here with our flags. True. Edited true. Let's see. Let's do a mesh here. Mesh flags plus equals gxe render flag mesh. We update the flags and we allow to update our mesh here. Okay, let's add a static object. Let's change the mesh. Well, we have some overlapping in terms of the the handle itself. Let's see. I think let's see. Oh, maybe we change that. Anyway, let's see. Add static object. Change the mesh here. Okay, we can change the mesh. We can change the material here. Oh, that overlaps. So is it because of the naming? I think it's because of the handle creation. If I change this to something like 1, 2, 3, I think everything should be fine. Yeah, I need to fix that handle creation issue. Let's see. Fix. Yeah, already. I fixed that one. But we need to fix that bug. right. Let's see. Okay. Yeah, right now we have that handle issue. I'll add some kind of hashing function, I guess. All right, yeah, we definitely want to fix that issue sooner rather. Yeah, you can just call me guide or guy or whatever. Great stuff. So now we can add an object, we can change the mesh. Um, Next will be the object position. Um, yeah, but we basically have a editor now. Or you can call me the dude if you want to. Dude. The dude. All right, let's see. Performance definitely got better after I removed that stupid mouse pulling. What kind of videos? No, well, I don't know. I don't know. I used to do machine learning videos, but um, yeah, I haven't done that for a while, but I might do that again. Uh, but I think that this project here will span so many months of content that it's probably unlikely. So yeah, now our system here actually allows us to manipulate the objects that we see here. It allows us to delete some objects. Well, okay, it doesn't update this list because I know why. I know why, because the delete function here doesn't actually uh, remove the actual game object. Yeah, thank you. I also think that it turned out quite all right, at least. There are definite ways of improving it, but um, yeah, for one, I have to change from that awful, uh, awful font, and I need to do some bordering, and yeah. Look at, as in DirectX Math, or this one? Well, I don't know. I never used GLM. Okay. Uh, if the let's see if this has a size, we will allow to delete. Okay, we aren't allowed to delete any more objects. This feels like some kind of like cutscene in Half-Life or something like that. We're in this weird state where we will move Paul around and he'll fall over. Okay. Oh, okay. Yeah, we could fix that. Flush. I mean, usually those math functions create a view matrix, so it defines a coordinate system for the camera. When you use the view and projection matrices to translate your vertices, uh, you translate from, well, first you translate from object space into world space by using the world transformation matrix for each object. Then when you have the coordinates of each vertex in world space, you use the view and projection matrix first to translate the vertices into the view coordinate system, which gets defined by these functions here. It creates a matrix that has it's a 4 by 4 matrix. How do they work? I'm not sure I can really answer that question. I mean, it's math, so the idea is you translate between coordinate systems. That's all. That's what we use matrices for. We multiply vectors that can contain points or actual directions, and we multiply them by matrices to transform their coordinate systems. That's all matrices. That's how matrices work in terms of 3D graphics, or in physics, or whatever. Well, the math behind it is somewhat simple because, yeah, in linear algebra you do transformations of vectors, and that's basically what you do. So a matrix um, changes coordinate systems. That's basically it. Yeah, so the look at function here creates a view matrix, which is the camera's internal coordinate system. It's also containing skew and translation, meaning the actual position um, of the coordinate system origin. So yeah, this function builds that matrix, and the um, FOV kind of stuff creates the projection matrix, which is a matrix that once you're in view space, you can use to translate into clip space, which is the 2D space. It stores the um, depth in the W component of whatever vector you transform by that. It's no problem. I suggest looking into 3D math and transformation of vectors in 3D space by using matrices if it doesn't really stick with you, because yeah, in linear algebra you do a lot of transformations. Also, the inverse matrix transforms everything back um, to the original state. For instance, the inverse view matrix translates from view coordinate systems coordinates into um, world space coordinates usually. And then the inverse of the object transform matrix translates into object space. And that's how we're going to do picking. We will translate a 2D coordinate in normalized screen space coordinates into first a view coordinate um, in view space, and then from view space into world space, and then potentially from world space into object space to do intersection testing, or even triangle testing if you want to. Yeah. Okay. Okay, we don't have any crash just because I delete objects. But yeah, if we don't flush the queue, we of course get some problems here. Mm, yeah, we can delete our static objects. Okay, so I was considering whether to do a so we could actually do a bit more of a simple function here on the renderer. Whenever we update our object, we could, oh, I think, let's see, since, okay, if we store our texture transform, well, oh, that's bad in terms of alignment. Yeah, we could, since this is not supposed to be very efficient in terms of speed, because we're working with static objects. Um, in our editor, usually the calls will come from our editor. We could actually create some flags here. Yeah, I know how you feel. I didn't understand any of this before I started working with DirectX12, and I had to be maybe 1 year deep into learning 3D graphics before I really understood it. Trying to learn AI and machine learning also helped, but yeah, and also studying the physics. Since physics and 3D graphics overlap a lot in terms of the math needed. So it's a lot of repetition and yeah, well, okay. So we could calculate a base offset and then do separate uploads for each part of these data here. Because we might want something like highlighting. If I click on an object, the whole UI should change, of course, to that object, but maybe we want to render it with a different color. Um, yeah, can I actually do Or maybe just a different material, actually. Maybe just a different material. Let's create a custom material here. Not in the lights, of course. Materials here. What information do we have? Well, we should clean up this also. I don't know. I haven't used any of them. They're probably all great. Okay, the diffuse albedo. And then the roughness, Fresnel. Okay. We could create something like a orange material here. It's not shiny. It's very rough. And let's try setting this material here. This is the base material. Picking material. Okay. So if we change the floor material to number 1, well, of course we reset the texture transform, which is why I want to modify the update function. Because I don't like that. Yeah. If I look into our UI here, yeah, and that should be a good library, I guess. At least from what I've heard. But if you're using voxel, I don't know. It's probably fine. Okay, let's see. So whenever we record a window here, we create a background rect with the specified color, bar color. That's not it. Add window rect, bar color, blah blah blah. Draw rects. We have exactly that color. That sounds nice, man. Anyway, let's change this update function, not this one. That's the initializer. We're not gonna change that one, but this update function here Let's create some flags and maybe even a const texture transform, which reminds me, I also need to modify the transform list whenever I delete something. Text transform. Let's do that. Let's do another define here. And as far as I remember, we will work in terms of the power of 2. We can also just do something like this. 1 bit shifted 2. I'm pretty sure it's the same. So if we do our calculator here and swap it to our programmer calculator, we will bit shift 1 by 2. 1 maybe. Bit shift 1 by 1. No. Bit shift 1 by 3. Bit shift 1 by 0. 1. Okay. Bit shift 1 by 1. Yeah, okay. So this is actually correct. This is equal to bit shift by 0. I have to consider, did I? Yeah, that means that actually I made a mistake here. The first flag needs to be set to 0, or rather 1. We set the flag that it is a static object. Okay, we don't want mesh here. We want texture. We want material. We want texture, material, transform. We want texture, text, transform. Okay, so these are our flags. Let's just implement them out here. Let's comment this out. Okay. We could also do like this. It will be exactly the same, I think. It might be faster though. Our flags will, this is the texture. Texture, there we go. Okay. We will move this. And for debugging purposes, we will do flags. Flags. So if we have the mesh flag set, we do that. If flags, well, texture, we copy that. Yeah, we will rewrite parts of this. Okay, actually we should swap these, which is easily done because we have created these. So this will be, we do mesh material. The flags will represent whatever underlying value we have, and we will always check against our definition of flags, so it doesn't matter. So we do like that. If we have a transform flag set, we will update this. Let's do the flags at the end for debugging purposes, and then well, usually we shouldn't be able to do anything, but without that. Anyway, uh, let's see, we will calculate our offset, which is an unsigned integer, unsigned int base offset, which will be like that. And this will be our base offset. We can now chunk this up. We can actually queue several uploads. It will be somewhat slow, but now we have some control over what values we update. And since we won't be using this to actually update static objects regularly, we won't be concerned with our performance right here. Okay, so our material is located as the third slot. So let's see, if we start by doing the transform here, we want to write from our world matrix here, and we only want to write hello, welcome. We only want to write the information inside the world matrix. Okay. Then we know the next part of this buffer here is our texture transform. This is just at the base offset. So if we wanted to do something like, let's just do a function where we set the texture transform. Let's look at our flags here. Text transform would be equal to text transform here. Transform. And this, of course, would be offset with the size of our world matrix here. And would be our texture transform size. What language I would use to make a logger? For what purposes? So we add to our base offset because we know whoops. Thank you. uh, for some reason it let's see, reset transform. There we go. Thank you. I don't know how long that had been happening. Let's see, I'll lock the components so they don't change. Wbook. I don't know what um, purpose your logger would be having, but yeah, I think Python is a great language to learn. Oh, okay. Thank you. But it all depends on your purposes. Are you doing scripting? Are you doing web applications? Are you doing systems programming? Are you doing performance critical applications? For instance, if you're doing something that is supposed to be fast and performant, I would never use Python. But if you don't care about speed, Python is pretty great. Let's see. So we change this into our material index here, and we add the offset of our texture transform. And then we, of course, will add our texture here, texture index, and add the size of this. So yeah, this should work, but I'm not certain. Let's try to compile. We have a problem. Function does not take 3 arguments now. That's true. We want to add our texture transforms here. POBJ. Well, I don't know. Texture transforms. It will be the same as the transform, I think. They are kind of mirrored. Let's see, I have an error somewhere. Oh, there we go. Whoops. Not transforms here. There we go. Let's see, update. Yeah. Okay. Let's see if everything works then. We add the object. Flag 0. Okay, we can't do that. Flags 4. Flags 4. 1. Okay, we can change the thing there. So parts of it work. But changing the texture here doesn't seem to do anything. Material texture. Oh, of course I need to copy the right data. Well, which I'm not. World matrix, texture transform here. Our draw call is simply changing our mesh, so that didn't end up being problematic. So now we should be able to change that. Okay. We will not get rescaling of the texture since we do not change the texture transform anymore. Okay. Great stuff. Everything seems to be working. Our flag system here is doing what it's supposed to. We update whatever parts of the object we want to update. And we simply queue it. All right, I should soon do a dinner break. I know this is not super performant, but yeah, I'm starting to feel hungry. All right. Um, uh, Yeah, so our system here allows us to swap materials and textures, meshes, check. Let's see. Kind of check. We need to add some scale, rotation, yeah, different stuff. And that means changing the object matrices. I'm considering how to do it optimally. Yeah. Anyway, we will, of course, also clean up some stuff here. Well, it will be tricky to represent the different components of the objects. Yeah, maybe we will use the object transform original data as well as the rotational data so that we can also always compute the required compute the required object matrix. Yeah, that's probably what we will do because our system right now does have some basic transform information from which the updated matrix could be calculated. Right now, our game object data here, our object transform actually has the position, the scale, and the rotation from which we could create the actual matrix itself. So we can always store our original position um, and just recalculate the matrix whenever we need to. Yeah, because we need to be able to do that to build a system where we where we can rotate and scale and move. I think that was where what was what I was supposed to say. Maybe this update here should be called in our application. Yeah, it works fine. Okay. So I wanted to remove the change texture, update texture thing here because it doesn't make any sense to have that functionality be a part of the UI since we now have direct editing here. Also, I really want to change that highlight color on the selected item. So let's see, inside of this list box item here, select it. Let's see. It's primarily blue whenever, but we could add a bit of maybe red and green here. Let's do like this then. Yeah, so that seems a bit more. We could, well, since the text is white right now, this is probably better until we get bordered text. Okay. Yeah, but anyway, since our system here kind of works already, I think most of the changes just require some work on the UI, some work on some math functions. Uh, yeah, so we're almost there. I did want to. Okay. Yeah, whenever we can do that, move, scale, rotate, we can actually start building levels. Although the the editor preferably should have some more functionality. Um, but yeah. Yeah. Yeah, I should probably go grab something to eat. Um, how are you guys doing? Great, man. That sounds good. I'm quite hungry and a bit tired, so yeah. That's why I considered doing the break. Mm. Yeah, I probably should. Yeah, I'll do a break. Um, I should probably end the stream as I don't know when I'll be back. Um, but yeah, thanks for everyone dropping by and hanging out and interacting. It was a pleasure to see every one of you, as always. All right, stay focused, stay strong, healthy, and take care of yourselves. Hopefully, I'll be seeing you around. If you found any of this entertaining, helpful, or just something else in terms of usefulness, feel free to comment, like, or subscribe. Yeah. Um, I might be back later today. I might not. It depends on how things go. Let's see. Yeah, but there's definitely some work left to do on the level editor here. But I think that we have created a great offset. Since the next parts of the work will be improving on the UI and maybe um, implementing some simple stuff um, in terms of actually editing objects. Um, well, I think that I might do some of the basic work off stream in between episodes, especially in the coming week. I'll have a very busy work week, so I probably won't have the time to do a lot of work on stream, and I might even be too tired to really do the streaming part, but I'll do some minor improvements here and there so the UI gets more usable, and we can um, yeah, work with our objects better. Since it's just repetitions and variations of what I've done. For instance, I want to um, create UI elements that might be labelless or uh, yeah, ordered on the same line. I might do different sizes. I want to do some checkboxes. I want to do some different controls. I also want to do a drop down, and yeah, um, I want to do different stuff like that, which means that there will be more UI work down the road. And well, it's not very interesting. It just needs to work. So therefore, it will be probably some fine small projects that I can do off stream. In terms of what we do here on the stream, I've been considering doing a matrix inversion math function that can be used to translate from clip space into view space into object space, or rather world space, and then object space, so we can do our picking here. Yeah, that will be probably will be more interesting, so I'll probably do that on stream, maybe today, maybe during the next weekend. Yeah, that's at least my thoughts about it. Um, I had really hoped that the level editor got done today. So yeah, maybe I'll push on later today. But yeah, we'll just have to see. Thank you. Anyway, I definitely need a break and some food to eat. Yeah, I'll just leave the stream here, AFK, and people can hang out, use the chat, interact, or whatever while I'm gone. Even though I might not come back for a while. Anyway, thank you again for everyone who joined the stream and watched so far. Hopefully, I'll catch you around. All right. Bye bye.